Okay, I'm just going to do one of these questions for number 6. I'll do part B with you. Basically, I just want to walk you through how this looks on the calculator. So I'm going to pull up a graph, and then I'm going to start typing in my function. So I've got negative 0.4x to the third power. Make sure you hit over to get down from the exponent. That's a common mistake. Plus 0.6x squared. Whoops. Got my variable, x squared, and then plus 3x minus 2. Make sure you hit minus 2, not negative 2. Minus 2 makes a difference. All right, then enter. So I have my function here graphed. So I've got this, and I can clearly see that there's a minimum point and there's a maximum point. Okay, so what I want to do is calculate those. So what we did is we did menu, analyze graph. And then obviously we do the minimum point. So if you're looking on here, where's the minimum? Well, the minimum is here. The graph does get to, you could talk about an absolute minimum, but we're talking about these local minimums and maximums. So as long as I click to the left of it and then drag over, see it's going to be like, here's your min, here's your min, here's your min, here's your min. Obviously if I go over here, it would jump to the other graph, but we want to go just right there in that region, okay? So I have that point right there. And then I'm going to go and do the same thing and calculate a maximum point. So from here to here would be my maximum point. Okay, now back to what the question is being asked. Sketch a picture of the graph. You can see that right here. I'm not going to do that. Find the local maximum and minimum. So here's the deal. If it said, what is the x value? Okay, let's go through this. So what is the x value for the min? Well, the x value would be equal to negative 1.16 it looks like. Now, what is it? It doesn't say specifically give me the y value. It does for x traditionally, but what? That means that's the y value. So the actual function's minimum is negative 4.05. Okay? So what about the max? We would answer it the same way. The x value is given as 2.16. And what is it? What is the actual max, local max? We would say 3.25. Okay, so that's how we do that. So now the increasing and the decreasing come from those. We're not using the y values in our answer, but we're looking at what the y values are doing. So the y values are going down, 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 down. So actually from negative infinity, the y values are decreasing all the way to that point, that minimum. So we say all the way to negative 1.16 because we use x values for our intervals. And then the inside part here is increasing. So we go from that negative 1.16 and we go all the way to positive 2.16. That's going to be increasing the entire way as far as the function's value. And then the function's value drops off. So the function's value goes from 2.16 to infinity. It keeps going this way, but the y values go down and down and down and down and down. Okay? So I hope that helped. Now, next question here talks about even, odd, or neither. So I need to see the algebraic support on this. And the way to do that, as you can see in the directions, is you show your teacher, hey, I realize that we're supposed to put in the opposite of x. Well, again, what that's going to do is replace this top x with the opposite of x. It's going to replace this bottom one with a negative x to the 5th power. And the reason is those are odd powers. Now be careful, just because you have some odd powers doesn't mean it's going to be an odd function. We'll talk about that. But basically, if you put in the opposite of x here, it will change those two values. Now, this fraction and all the fractions are kind of tricky. Look what I do in red here. If I asked you for the opposite of this function, you would multiply it by negative 1, but you would do it not to the top and the bottom. You would do it to either the top or the bottom. So actually, if you look down here, if we're exploring what the opposite of the function is, that could be equal to the opposite of x over x to the 5th minus 1. Change the top, but don't touch the bottom. Or you could think of it as leave the top alone and change both on the bottom, because we'd have to distribute that negative 1 through. So here's your progression of questions. Clearly this right here, when we evaluate at the opposite of x, is not the same as that. And then we ask, oh, is it the opposite? Well, it's not either of these. So in fact, we actually analyzed it and realized it's not So we would call it neither in that case, okay? Now this one, a little bit more straightforward in my opinion. When you replace and do show your work of replacing, you will get x to the fourth plus 3x squared. You get the exact same thing, and when you get the same thing, we call that an even function. Remember, we said ooh, yes. So origin, odd, you get the opposite. Y-axis symmetry, you get an even function, and it would be the exact same when you plug in the opposite of x. So when I plug in the opposite of x here, we will see this is negative x cubed because it's an odd power, and then minus 3x. This is the exact opposite of this. That's the exact same as if I was to take this and multiply by -1 and distribute. That's the exact same thing. So we say we get the same, so that would be an even function. Oh, I don't know why I just spoke that through, and I'm not going to re-record. I was just going through the motions to finish the video. I totally misspoke. I hope you didn't stop. This is not the same thing. Why did I say that? Now we can have that talk. We get here. Is this the same? No, it's the same as if you were distributed a negative, but that means it's the same as the opposite of whatever that function is. So we do get the opposite. Again, I'll slow down here. That is the opposite of the original one, so we call that odd. Sorry, I was being a little odd there as well. I hope these videos helped and you are starting to get ready for your